Welcome to the third of 5 modules of the WHO course in Environment, Climate Change and Health for practitioners and actors guiding policy change. This module provides you with essential information on key environmental health risk factors, including chemicals, radiation and solid waste. These are the learning objectives of the third course module. This module outlines the most important exposures, health impacts and actions, interventions and policies on chemicals, radiation and solid waste. After you have completed this module, you will know about the sources of exposure and the health risks posed by chemicals, radiation and solid waste, what types of interventions can be implemented to address these health risks, and detailed resources on designing and implementing interventions. We will start with chemicals and health. We are surrounded by myriad chemicals in our day-to-day lives. Many affect our health, and the effects can be both positive and negative. WHO has identified 10 chemicals of major public health concern, which we will go through now. We have already talked about different air pollutants and their health impacts in Module 2, so we will not go into more detail here. Exposure to arsenic occurs predominantly through the consumption or use of groundwater that contains naturally high levels of inorganic arsenic. Arsenicosis, which results from chronic arsenic poisoning, can present through skin lesions, neuropathy, gastrointestinal symptoms, cancer, and other diseases. Exposure to asbestos occurs through the inhalation of asbestos fibers, such as in factories handling asbestos or in housing and buildings in which asbestos has been used. Asbestos causes lung cancer, mesothelioma, and other cancers, as well as asbestosis, which is a form of lung fibrosis. Exposure to benzene can occur at work, at home, or outdoors from the use of benzene-containing petroleum products, including motor fuels and solvents. Active and passive tobacco smoke is also a significant source of exposure. Benzene has been associated with a range of acute and long-term health effects and diseases, including cancer and hematological effects. Exposure to cadmium occurs mainly from the consumption of contaminated food, active and passive inhalation of tobacco smoke, and the inhalation of cadmium by workers in certain industries. Exposure of children, which is of particular concern, results from the disposal and recycling of electronic and electrical waste, as well as toys, jewelry, and plastics containing cadmium. Cadmium is toxic for the kidneys, as well as the skeletal and respiratory systems. Dioxin and dioxin-like substances are persistent organic pollutants that accumulate in food chains and finally the human body. These are unwanted byproducts of combustion and various industrial processes such as chlorine bleaching of paper pulp and smelting. PCBs, even though their manufacture is now prohibited and their use in equipment is to be phased out by 2025, are still released into the environment from the disposal of electronic equipment and waste. General population exposure to dioxins and dioxin-like substances occurs mainly through the consumption of contaminated food, but higher levels of exposure can occur in occupational settings. Exposure to dioxins and dioxin-like substances has been associated with a range of toxic effects, including chloracne, reproductive, developmental and neurodevelopmental effects on health, cancers, and many others. Children are exposed through breastfeeding and are most at risk of developmental adverse effects. Excessive fluoride intake can occur through the consumption of groundwater that is rich in fluoride. Both too little and too much fluoride can be harmful for health. Adequate fluoride intake reduces dental caries, and excessive intake can cause tooth enamel and skeletal fluorosis. Even though reductions in the use of lead in petrol, paint, plumbing, and solder have resulted in substantial reductions in population-level mean blood lead concentrations, there are still significant sources of exposure, particularly in lower-income countries. Lead affects the neurologic, hematologic, gastrointestinal, cardiovascular, and renal systems. Children are particularly vulnerable to its neurotoxic effects, and even relatively low levels of exposure can cause serious and in some cases irreversible neurological damage. Mercury releases occur from coal-fired power stations, residential heating systems, waste incinerators, and mining for mercury, gold, and other metals. Once in the environment, elemental mercury is naturally transformed into methylmercury that bioaccumulates in fish and shellfish. Mercury poses a particular threat to the development of the unborn child and early in life. Mercury exists in various forms, such as elemental, inorganic, and organic, which all have different toxic effects, including on the nervous, digestive, and immune systems, and on the lungs, kidneys, skin, and eyes. Exposure to highly hazardous pesticides occurs through environmental contamination and residues in food and drinking water. They are also used intentionally for suicides. Exposure to highly hazardous pesticides can have acute or chronic toxic effects and are of particular risk to children. Exposure to selected chemicals causes about 2 million deaths each year. This is really only the number of deaths from a small number of chemicals and does not include air pollution. Chemicals are everywhere, and exposure to them occurs through many sources and routes. Important sources of exposure are, for example, food, water, air, direct exposure to chemicals in the workplace. Important routes of exposure are breathing contaminated air, ingestion of contaminated water, food, soil, and dust, and skin contact with chemical agents. This diagram shows exposures to chemicals during their life cycle and links those chemicals to certain policies and programs. In this diagram, chemicals are classified as naturally occurring contaminants, raw materials, manufactured products, waste and byproducts, and combustion products. As there are so many different kinds of chemicals, there are also many different health impacts that can be linked to exposure to chemicals. Unintentional poisonings may happen at home or at the workplace. Chemicals that are frequently involved in unintentional poisonings include methanol, diethylene glycol, kerosene, pesticides, and others. Other health impacts include self-inflicted injuries, which often involve the deliberate ingestion of pesticides in a suicide attempt, as well as cardiovascular and respiratory diseases, cancers, chronic kidney disease, developmental effects, and others. As before, the percentage sign after each health impact indicates the fraction of disease that is due to chemical exposure. This and the following slide list selected actions and policies for increased chemical safety. Implement the WHO Chemicals Roadmap to enhance health sector engagement in the strategic approach to international chemicals management. Implement the International Health Regulations, or IHR, which includes the strengthening of core capacities to deal with chemical incidents and emergencies. Implement the health aspects of multilateral environment agreements, such as the Minamata Convention, the Basel, Rotterdam, and Stockholm Conventions, and the strategic approach to international chemicals management. Establish health-based guidelines for chemicals in water, soil, food products, and occupational exposures. Establish and strengthen poison centers in all countries. Promote communication of relevant information and training to enable informed decision-making throughout a product's life cycle through proper classification and labeling. Further guidance on how to improve chemical safety for health can be found in the Compendium of WHO and other UN guidance on health and environment. You'll find the link at the bottom right corner of this slide. In an accompanying series of slides, you will also find useful resources on chemicals and health.